Section 3.2 Part 2 is a lot of repeating of what happened in Part 1 with one additional concept. So our goal is to be able to identify functions and represent relations using graphs and maps. So reminder, a relation is a pairing of numbers in one set with numbers in another set. The domain is our x values, also known as the input. The range is the y values, also known as the output. All right, so here's an XY table that is oriented differently. It's horizontal as opposed to vertical. So this first example is asking about the age and length of 5 alligators. So age is our x, length is our y. So if we represent the relationship between age and length using ordered pairs, we've got to make sure that we put our ordered pairs together correctly, like this. Okay, so I'm not going to continue all the way through. We're just going to go ahead and write those ordered pairs. So when x is 2, y is 32. When x is 4, y is 59. When x is 5, y is 65. We've got another x of 5 with a y of 69. And when x is 7, y is 96. So our domain is our x values, 2, 4, 5, and 7. Those are already in order. Okay, so the domain, remember we do not duplicate, 2, 4, 5, 7. The range is our set of y values, so 32, 59, 65, 69, 96. Those are also in order already. So 32, 59, 65, 69, and 96. So if I asked you whether or not this was a function, we would say no, this is not a function due to the fact that the x value of 5 is repeated. It has 2 different y values. So it's not a function because x of 5 has multiple y's. Okay, so I would like you to do numbers 2 and 3. I want you to identify your domain and range of these relations, and I also want you to answer, are they functions? Okay, does every x have exactly one y? So make sure you list out your domain and range in order from smallest to largest for each of these problems. Do not duplicate any numbers. And answer the question, is each of these relations a function? All right, so in looking at number 2, our domain is 0, 2, 3, 5. Our range is 1, 4, 7. Because each x is only there one time, this is a function. Every x has exactly one y. In number 3, our domain is -3, -1, 6. The range is -1, 0, 2, and 4. But this is not a function due to the fact that the x value of -1 has more than one y. So this is not a function. Because our x value of -1 has 2 different y values. So a couple new things here is we've got functions, okay, or we've got relations here technically. We don't know for sure whether or not they're functions. And we're given the domain. Okay, so it says d equals 0, 1, 2. So these are our x values. We need to figure out what the y values are for each of the x's. And we did this in the warm-up in the previous lesson. But now it's just kind of written in a more mathematical way. So if we want to identify the range, it means find the y values when we are given our x values. So we're going to take our x values of 0, 1, and 2, and now we're going to plug them into our function. So here's how function notation works. It says f of x equals 3x minus 4. So it means the function value for a given x, and the function value is the y value. So we're going to plug in 0 first for x. So f of 0 equals, we're plugging in 0 everywhere we see an x. So 3 times 0 minus 4. Well, 3 times 0 is 0, minus 4 is negative 4. So f of 0 equals negative 4. So this literally means when x is 0, y is negative 4. So the y value is negative 4. Next, we're going to plug in our x value of 1. So we want to find the function value when x is 1. So we're plugging 1 in wherever we see an x. So f of 1 equals 3 times 1 minus 4. 3 times 1 is 3. 3 minus 4 is negative 1. So f of 1 equals negative 1. So again, this literally means when x is 1, y is negative 1. So y is negative 1 when x is positive 1. And we've got one more here. When x is 2, let's find the y. So f of 2. So 3 times 2 minus 4. Well, that means f of 2 equals 3 times 2 is 6. 6 minus 4 is 2. So when x is 2, y is 2. Okay, so our range then for this function is our y column. So our range, to answer the question, is negative 4, negative 1, and 2. Okay, so we were to identify the range. Okay, so we're going to do number 5 in the same exact way. We've got f of x equals x squared plus 5x plus 2. And we are told that our domain, our x values, are negative 2 and positive 2. So we're going to plug those into our xy table. And we want to know what is y when x is negative 2. So we're going to plug in negative 2 for x, wherever we see an x. So f of negative 2 equals, especially when you're plugging in negatives, you've got to enclose them in parentheses. So negative 2 quantity squared plus 5 times negative 2 plus 2. Definitely want to show more work with these. So f of negative 2 equals, when I square negative 2, I get positive 4. 5 times negative 2 is negative 10, so 4 minus 10, drag down the plus 2. So f of negative 2 gives us 4 minus 10 is negative 6, plus 2 is negative 4. So when x is negative 2, y is negative 4. And finally, we want to know what is our y value when x is 2. So we're going to plug in 2. So f of 2 equals 2 squared plus 5 times 2 plus 2. Continue dragging down. F of 2 equals 2 squared is 4 plus 5 times 2 is 10. Drag down the plus 2. So f of 2 equals 16. So when x is 2, y is 16. again, answering the question, what's the range? Well, it's our y values. So our range is -4 and +16. Okay, so this is what we call function notation. Okay. All right, so we did this in our previous lesson. We can represent a relation using a table, a graph, or a mapping diagram. Okay, so as a reminder, we've got these ordered pairs. Graph, we just plot the ordered pairs. A mapping diagram, we put our x's and our y's in there. We put them in order from smallest to largest, and we draw lines. Okay, so I would like you to complete example 6, representing these ordered pairs as both a graph and a mapping diagram. Okay, so let's take a look here. Hopefully you plotted these ordered pairs correctly. Here's our mapping diagram. Notice our x's are our inputs, -1, 2, 3, and 4. Our outputs, 0, 1, 2, 5. And we draw lines to represent their relationships, their ordered pairs. Now, if I asked you, is this a function? Remember, a function, for every x, there's exactly one y. So we watch out for x's that are there twice. Okay? Well, in this particular case, it's pretty easy to see that our x value of 3 has 2 different y values. Okay, so the x value of 3 is a cheater. Therefore, this particular relation is not a function. So not a function. This is a relation only, because x value of 3 has 2 y's. And we don't care what the y's are doing, how many times they're there. We just care about the x values. Every x can only have one y. So we're looking for duplicate x's. So if we look at numbers 7 and 8, is the relation a function? Okay, so when I look at these ordered pairs, I'm tuning into those x values. 5, 2, 4, 7, 5. Because I just said the x value of 5 twice, this is not a function. Okay, x of 5 has 2 y's. For number 8, look at those x values. 3, 1, 5, 2, 4. None of the x's duplicated, so therefore this is a function. Okay, because every x has exactly one y. Okay, so we're keeping an eye on those x's. All right, and one final thing is the vertical line test. And the vertical line test is a visual way that we can determine whether or not we have a function. And here's what we do. If we can draw a vertical line that goes through more than one point, then our relation is not a function. So if I look at this particular example, the very first one, I can obviously draw many vertical lines that I'm hitting more than one point. Okay, so that vertical line is hitting twice. This vertical line is hitting twice. And all it takes is one vertical line to hit twice. Okay, so this particular function, or this particular relation, is not a function because it fails the vertical line test. Okay, so we've got a couple more problems here at the end to wrap up dealing with this vertical line test. So we want to determine whether the relation is a function. So we're going to draw a whole bunch of vertical lines. Now number 9 has a bunch of just individual ordered pairs. So I'm just going to draw lines where I have ordered pairs. Ooh, 1 point. Fine. 1 point. That's fine. 1 point. That's fine. 1 point. That's fine. 1 point. That's fine. So this one is a function. Okay, passes the vertical line test. Let's take a look at number 10. Draw lines where we have points. 1 point, 1 point, 1 point. Uh-oh, 2 points. So my last vertical line over here on the right-hand side hit more than 1 point. So this one is not a function. So fails vertical line test. And number 11 has 4 different graphs on it. So I want you to answer the question, which graphs are functions and which graphs are not functions based on the vertical line test. Okay, so we've got graph 1, graph 2, graph 3, graph 4. What's my function situation? All right, and hopefully you have determined that only graph 1 is a function because it passes the vertical line test. Graphs 2, 3, and 4, we have vertical lines that hit at more than 1 point, therefore they are not functions. Okay, so a couple things added here for section 3.2. Our vertical line test, our visual representation. If we hit 2 points with a vertical line, not a function. In addition to, going back up here, figuring out our range based on a domain that we are given. Okay, so domain is x's, so we fill our x values into our table, and then we take each x value, plug it in wherever we see an x, and then we just do our PEMDAS, we plug and chug. And the result that we get is our y value. Okay, so then we are able to find the associated y's given our x's, and then establish our range.